It's like I literally no, I didn't. So I'm just like, and I know what's the issue, but it's not making sense.
It could be live, just wait like 2 more minutes in case people join online. 2 more minutes. Soon choose the slideshow.
Yeah, show your face.
So hi everybody, thank you for being here. Nancy. I'm Nancy from PyLadies Amsterdam. We are an organization who strives to increase inclusion and diversity in the Python community through workshops and events. And such as today, we are hosted at Elastic. And today we will have Nastia Havriushenko. Okay. She will be talking about how to implement our Retrieval Augmented Generation with Elastic. We also wanted to introduce our new co-organizer. So as soon as she's in the room, we will do that. She's waiting for people that are joining us in person at the door. Aliona, any words?
Later.
All right. So we turn to Nastia. Yes.
So, yeah. Here, so it's my camera on the stream and also for recording. So thank you all for coming here. It's my first event in the studio at Elastic. I'm Anastasiia Havriushenko. I'm working as a machine learning engineer for like over 7 years. I'm being a data scientist, being a machine learning engineer, data engineer, MLOps engineer. So I tried some stuff. And now I'm happy to be part of ML data team here at Elastic. And we're going to talk about RAG. Why? Because we all talk about LLMs and chatbots. And now we all want to have it in all our products, right? So a question is how to make it more trustworthy, how to make it faster, how to lower the cost. And we will talk about that. Yeah. That's an overview of today's presentation. We put the knowledge threshold low, so anyone can attend it. So we will talk first about distance to each other. And then, well, we will encode it somehow in the computer, but we feel as humans, we feel that cats and dogs are a bit closer together than like empire and a chair. And for computer, it would be all same shit with the same distance in all this multidimensional space. So what we do, we come up with some requirements for that. And we want to encode it in a way that it would be meaningful. It would be meaningful in a way that we can see the distances between some words and phrases. We can say that, like, little boys walking, then it's quite close to sad boys walking, and it's a bit more distant from a cat. And then we can say, for example, that little boy is running and then little boy is walking. It's kind of same distance between a dog is walking and a dog is running. So we want to have some measure of distance and keep this measure similar, and also have some concepts that relate to each other closer in this multidimensional space. And then for other concepts, we want to have a higher distance. Like, we can then describe it mathematically. We can name it as a field. We can define operations. So then we can define, like, for example, we have a kitten minus cat is equal to puppy minus dog, and then maybe a child minus human. If we consider humans as animals, we supposed to, I guess. If we go with Darwin theory. So something like this we need to keep in mind. And how it's implemented on this stage of our development, we don't need to care too much as developers, because it has been implemented already, like, for decades, as NLP was presented. But it would be nice to know some of these properties. So, for example, we know that there is some embedding already, and we can like get it, for example, from Hugging Face or from other registries with these things. And then as embedding, it gives you a mapping from a word to a long vector. What we want then, we would like to see how does it look. So then we project it into 2D picture here. And for example, we have a data set with movies. And here, for each movie with a description, we have a vector. And we would like to just visualize it for fun and understanding how the vectors work. So here, for example, we have Western movies. We can see that they belong to one of clusters on this picture. So there's also a bigger cluster on the left, which is Bollywood movies. I can spoil you that this is Hollywood movies. And so here is like cartoons and anime. I guess here's anime. So they belong to movies and cartoons, what we would expect. Yeah, that's some good properties to keep in mind when we think of embeddings. And that's a good start to work with text in order to translate it in a computer comprehensible format. We talked about the words, and then for movies, there was actually a chunk of text. So how do we jump from one point to another? We can split it into chunks, literally. So for a big document, if we will, for example, calculate a vector for each word and then sum it up, well, it would be a point in this multidimensional space, but it would be quite blurry. So what we would like to do is actually have it more precise and split it into chunks where we can define the length of each chunk, and we can define a splitter. So it can be like we can split by sentence, then we use a delimiter as a dot, or we can split just by space, or we can split by a new line, depending on the size of a chunk we think of. So we have a document. It could be large, it could be like Wikipedia page, or it could be some of your company inner data. So something like, it could be like all your Jira tasks with descriptions, or maybe it's not that much information, depending how you document stuff. So you have document, you split into chunks, and then all these chunks you can then use embedding model and have the vector per each. Good. You have vectors. Next question would be storing vectors. It's quite boring because, yeah, like you need something where you can store, for example, your document or a pointer to document, and then your vectors. Usually it's called like a vector database. It can be optimized, so there's different methods to embed text. So there's like sparse embedding. So then maybe you can optimize with zeros or missed parts. So you can archive it better. So it's dependent on what vector database you are using. You can also choose the embedding model you are using. Also, you can use you can think of what type of data you're using, because so far we were talking about text, but actually you can work with other types of data, such as audio, video, images, and it's still about you have something not really comprehensible for a computer, and you just need to map it to the vector or to numbers, literally. So it's also nice to keep the properties we talked before in this case, because, for example, easy example would be you have the database with images and you need to search through them. So you want to find like some pictures with dogs, and then you can describe, oh, I want a dog playing with a human in a rainy day outside. So then ideally you can take this sentence, make embedding, have this vector, and if you use a similar embedding for that, or if you use some kind of neural network between them, you can also have the embeddings for images and have them stored in a database, and then run a search over all the images and check what the images you have that are closest in this vector space to your search. Maybe they could be like, maybe you don't have this picture and then they will be quite far, but then you can also, with certain probability, say that they don't exist. So it's good to keep in mind that you have embeddings and you can use them for different type of data. Good. We have embeddings, we need something to generate context. I would not go too much into details how NLP works and what's been done on that field, because this lecture is not about that. But what I would mention is kind of the simplest picture of a node, of a cell of networks. So imagine you have simple text, then you use embedding and you convert this to vectors. Then you have some metrics there. And what you do is like you multiply this vector by some metrics, you add some extra weight, you do that, you probably like add some parameters over here, you do that here, and then you like use a decoder from here to text back. So it all starts with embedding, and then you use some matrix multiplications, let's say, to get some answer from your NLP model in case like you need to chat with it or you need to generate text. Yeah?
In this case, it's like comparing cats to dogs, as in question to an answer.
Not really. So it's more about here, before we were talking about embedding, so how to encode words into vectors. So if you need to ask, where's my dog? You will write it here, and then it would be encoded, and then you would get an answer like your dog at home, for example.
And it seems that there's some sort of similarity between that question and that answer, right?
Yeah, so what I was going to say that like if you would ask where's my cat, it can also answer your cat is at home, because cat and dog is similar. But actually what you're asking, like similarity between answer and a question, is more about that neural network. Even in this simple format, it tries to guess. So, and how do you train it? Usually you give a lot of text to it, where you would have already a sentence similar to the question sentence. So you would know that cats and dogs, how do they behave? So usually like they can be at home, they can be playing outside, but they probably don't go to work. So then it would try just to guess word by word what the most probable answer you would get on this point. So yeah, did I answer your question?
Yeah, definitely. Thank you.
So yeah, that's a simplest representation of an NLP model. And then how do you train all these weights? As I said, you just give a lot of text. So you just give a lot of text, and then it learns what the syntax of the language, what's probable properties those entities can have, what they can do, what they can't do, how usually you use them, and then it just blindly tries to get, like tries to answer your question based on what it knows about these objects. Of course, the problem is that it can answer you, like, where is my cat? Your cat is at home, but then your cat can be not at home. Maybe you don't have a cat. Maybe it's at your parents' home, but it doesn't know it, because the most probable answer in the data it has used to learn on is that your cat is usually at home. And then, like, I don't know, what the second probable could be that your cat is outside. Yeah, something like this. So it would not give you the relevant answer. It would get you just the most human-like answer. So as all humans, they can be wrong. So a next step would be like to make this system more complicated. So there's a lot of ways how you can do it. You can change what's inside each of these cells. You can change how they are connected to each other. So here, as you see, they're connected like in two directions. So there was like a lot of work done on that field, how to, what the reasonable complications you can add to NLP networks to make them work better. And then since they grow and grow, the question would be how to train them. And then you can also, like, for example, you can try train one layer by layer. Or you can pre-train it on the most like larger data, most broad data, and then fine-tune it on your own data. So there's many techniques how to do that. You can look it up, but that's basically, I'm talking about like the history of NLP. So that's what has been done already for decades. And now recently we all heard about ChatGPT and about LLMs as large language models, and they're just larger. So here, imagine you have like hundreds of billions of parameters, and they all can be trained. And what happened that if you have it big enough, then after some level of training, it feels like it does magic. It feels like it's actually a human talking to you. And then, that was quite amazing. And even for chatbots, you can find this picture in Google that even for chatbots, people started to add in some adjectives as they are humans. They would try to guess their character, what they can do and what they can't, how to talk to them. So it's quite impressive how they try to humanize all this just statistical computer models. And then that's basically evolution. And there is much more. So now every big company tries to have their own LLM model inside. So like Samsung, Huawei, so on, they try to all use already existing and pre-train it in some hidden way or open source way. So anything they want, but many companies now try to add their LLM technology as part of their product. Yeah, it's quite funny, especially like Microsoft. I think something went wrong with that. So today, that's the main point of my presentation. We want to talk about the challenges and about what has not been done yet. So as we talked before, and probably as you all experienced that with ChatGPT, you know about hallucinations. You can ask it, when did humans colonize Mars? And it would say like in 1985. So it will get your answer probably. So, and it's okay when it's just for fun, when you're just with friends drinking beer and like guessing when ChatGPT will give you a wrong example. But probably it's not all right when your user chatbot, your inner chatbot to, well, even to give some assistance to people, you don't want to give them wrong answers, so they will be getting more and more stuck and more angry. But even though like you can also work with more sensitive data, and then the mistake can be quite sensitive for you in the end. So hallucinations is quite a big challenge we all heard about, but there is more. So another one is lack of domain knowledge. We know that all these chatbots available now, like ChatGPT, it has been trained on open source data. It's like a large corpus of data. It's like it's not everything what is available in the internet, but it's quite impressive, right? It's more than we all can know or remember from now on. But still, if you have your own company and you want to have a chatbot pre-tuned for your own data, so you don't want to give like just general answers about moon and I don't know what the capital of country is, but you want to have something really precise, how can you bring it to that? And if you say like, okay, I will pre-train it or fine-tune it or retrain it, then the question is compute. Of course, and computes mean money. It's not just, it is time and it is money. And then, okay, you use your domain data, you consider retraining, but what about if your company is changing and your policies, they are also evolving? So you need not only pre-train it to your like domain knowledge, but you need to keep it up to date. And to do that, you will have to periodically retrain it, right? So Then the question is like, how often, how much cost, and is it actually given better results after that? And you still will need to measure it because we still have hallucinations in general as a problem. And even if it gives you good results, you still need to kind of retract what is the proofs of this good results. Because maybe people would not trust you even if you have like perfectly trained model. They will be still like, I don't know, I will better ask, like wait for like human assistant because this bot, nah. Yeah, and the last concern is actually the privacy. For some applications, for example, you can be a bank, or like in the Netherlands, you can be this platform that you use to sign up contracts online. So you can do it with your signature, and then imagine for each user, you have the database of all the contracts they signed. And you want to make it actually searchable, and you want to allow people to ask and answer questions about that. So, which means like you have a lot of domain knowledge, you have a lot of concerns with privacy as well. And they're changing quite fast. Imagine like you can sign up contracts every day, or you can be a user that signs up contracts like twice in your life, depending on what you have. And then like, do you pre-train a model for each user? Or do you have the one big model that trained for all the users? But then how do you make sure that some users would not have access to the data of other users? So that's not something that you can consider even, because that's a lawsuit. So yeah, that's the main challenges we have in this field. And we will talk like from the most naive to the more smart solution, like more a sustainable solution in this area. So first solution is like to train it all ad hoc. So to train it all on your machine. So you have here some open source models. Well, you can also construct your own LLM model, or you can use like Hugging Face or OpenAI. And then you just train it from scratch. So you train it with your domain data and you train it with the open data to make it work. So that's a most naive approach. Like you will still have problems with how to update it. Like, and training like this is enormous. Like that would blow up really fast, and it's really expensive. So we want to like outsource part of these trainings. And if we do that, we can consider to have already pre-trained models on all the open data. They can be done. So we have already it's already available. Like you may need to pay a subscription to it by request, or it can be open source. So you have the model, and then what you do is you fine tune it. So you train the last layers of it with your domain data to make sure that it's like you override some results. So to make sure that it actually looks up to your domain data, not to like general knowledge from internet. So it can be done. That was one of solutions quite long time. But still, if we got the answer, we will not know how reliable it is. So we don't know, can we trust it, or maybe it's just hallucination, and we don't know the process, how it's been generated. So we get into the main point of this presentation, and here's some animation. And I see you're tired, so we're gonna have a break soon. Don't worry. Yeah. So then here we go to the RAG solution. And what we do is we have the question still from a user. And then what we do, we also look up in our business data ourselves. So we convert it to vector, we go back, and then we have all this vector database with our data that could be docs, images, whatever. Like for now, we will work with docs. So we have text here converted to vectors, and in the most naive approach, you just convert the question to the vector, and then you kind of try to find the closest responses you can get here. And you just add it as a context here. Of course, for the models, they have their window of memory. So you can't just the most naive approach would be to just give your business data all of them, right? So why would you need to pre-select them? But then a different model, they have different window to remember information, but it's still few pages, let's say. So on that regard, you need to pre-select some data that are the most valuable for this question, and you add it as a context here. And then you still give it to the neural network, to the LLM. And then you don't need to change it. You already created the question with wrap it in the best information you can find. And then you just give it to the network, and you kind of say do what you do best, just to summarize it and write it in a more human way. So write the response as it would sound if a human just read all the documents and provided the answer. And that's the idea, what we have. Do you have questions? Yes.
Yeah, I work with a lot of people who aren't very data savvy, and sometimes they have questions not about documents but about tabular data. So oh, where do I find the growth of this from last year, and what was the weather data at that time? And they can't do SQL, and I wonder how this model could work in either writing the SQL for them or retrieving from a tabular source the right answer, and that can't be that can't hallucinate, right? It has to be correct. So do you have experience with that sort of question?
Yeah, so for that, it depends on the size of your data, this tabular data you have. But so what you can do is you can give the, you need to decide, do you actually write a SQL? So you can also train this part to give the best information to write a SQL. And that it will be one solution. So basically here, your business data would be to describe how to write a SQL and describe what kind of data you have. So describe all the tables you have, all the connections with tables. So kind of what your data engineers know, the data architects, database architects. So that would be one solution. Yeah. And then then it will write a SQL, and then you can get it, and then you will wrap it. Yeah, another approach would be less automated. So you still, then you kind of ask, so you have a question, and then you have all this business information. So yeah, you ask the ML, the LLM to provide you hints for SQL, and then you have some code in between that does a SQL, because SQL rules, we have we have Copilot, so we have some tools that actually create quite good code, but it still can fail. So it's better than to think of some rules, how you create the SQL, really strict. So you have some names of databases like here, and then you have like some merge stuff here, and then you have some filters here. So like you create a template, add it to the like business data part, and then it would work better. So you need really to make the area really strict and defined, and then it would work quite well, actually. And also the answer could be, I don't know. So it's also important to check if maybe it fails, maybe like it's possible to find the answer, but it just fails because it's too complex. But it's also important to make some checks that I don't know answer.
Thank you.
Yeah.
So how is this privacy secure? Because from what I understood, the context window still has sensitive data probably.
Yeah, so for privacy concern, here, like if a user asks something, like imagine you have the documents per each user, then here in business data part, you would have only documents that belong to that user, not to all the users in your database. So then a user can have access only to their documents. So, and then if you don't like this part with like making a request to somewhere and getting back, then you can have it inside. So then, but it's still like you don't expose all the data from all the users. That's a point.
But you are exposing it still to the.
You're exposing it here still.
Yeah.
So then you need to have it local. Yeah. And also one of good parts of that as part of respond, you can name and link the documents you use to generate this response. So then you make it traceable. And then a user, like, they can see not only why they got certain response, but also how it was created. And then maybe it could be like really simple question, like something about your policy at your company, and then you got a link to Wikipedia that relates to it, or certain links. So it could be not a simple question, it could contain of like 3 pages, but then you have all of them in one part. Any other questions? Yes.
Say, for example, that I work in pharma, and periodically there are new names of drugs,
Yeah.
like elasticonics,
Yeah,
making
yeah.
things up. How would you improve the quality of the retrieval metrics? Would you use Elasticsearch as a search engine or as a vector database?
It's a vector database. So, and then for retrieval part, so I didn't emphasize it, but it's then you have like additional ML part here, and so then you can retrain it.
Okay, because like the tokens of this new name
Yeah,
is
they
not
don't
in
exist.
Ada or Da Vinci or.
Yeah.
Thanks.
Yeah, so then you keep it here, so you don't need to retrain this part, so you don't touch the big LLMs, but then you need to like adjust it here. So then you label it as a new product form, and then you have a description to it, and then you make your retrieval like understanding the new code for it.
Thanks.
Yeah. Anything else?
Sorry,
Yeah.
size-wise, how much smaller is the retriever respect to the LLM?
The size of what?
So the whole thing, we don't retrain completely the LLM because it will take too much time, but the retriever, we can readjust it after some time. So how much training time are we talking?
It depends, right? It depends on how custom you want it to have. So you can have it really simple. You can have it as just like a search engine for your vector space. Or you can have it really custom as quite profound ML model. And then you have like metrics. So there is like in the end of this presentation, there is a link to the page, and then you can check the benchmark, depending on like what you exactly want. Because it also depends on the size of chunks you are using, right? So how much you give, then it needs more parameters and more like space to work with that. So
Yeah, makes sense.
yeah, it's quite depends like how far you want to go in this direction of improving it. There is another slide for like really detailed architecture of that. So how does it happen? So user has a question, then you have this embedding model, then you convert it to vectors, and then you do similarity search. And then you use the Elastic as just a vector database in just really simple case. And then you get the similar document, you add it to prom, and you make it go back to LLM and then to a user. And then like you can improve this part. So you can do really naive similarity search, or you can make it more profound. And then it's also a question of compute. So depending on what database you use, it's also about the request and response and how does it work with that. So like I will show you how it's done with Elastic, but there's other options available. And then like with Elastic, we take computes on our side, but then there's some option that you like have a compute on your local machine or like in a cloud or somewhere else. It's getting quite popular, this methodology. So now at Google, they also just announced that they added it. So like I would expect that big clouds would add it as a part of their functionality. Yeah.
So are you talking about the VectorDB or the VectorDB with the compute to do the search qualification?
Yeah, so it depends on a database itself.
Yeah.
So like with our database, we do compute on our side. With also cloud, you do compute in the cloud. With some databases, you can use it just as a storage, but then you do all compute on your side. So really depends. It's also about cost, like what, like maybe it's also about sensitive information. So there's quite some stuff to consider. I guess it's nice to have a cloud or something integrated to cloud or something after scaling, because it really depends on how many requests you have. So you talk back and forth. It could be like up hour when, I don't know, all people are online in the morning and they're checking products and they're texting you, or it could be at night when all the assistant people are at home, and then there's a lot of people like texting you, and then you use a chat bot for that. So it should be quite scalable. So then I would advise to consider some other options. And yeah, we are good to go to demo, and we will have a break for 5 minutes to get some drinks and also to install, like to make sure if you want to use your laptops, you can open it and got access to it. The password is just right here. So you need to go out of this room and get the password right there. Yeah, let's meet at 7:30. And let's check how much. Okay, I have still enough.
Yeah, I was gonna ask.
Yeah, you can. Yeah, I can show you where.
Sì. Ah sì. Sì.
I can't show you, that's a problem, you know.
Like we would do that?
Yeah.
Many people just try to do itself.
our presentation. Right, so that's a repository for this event, and like in the README.
Just 1 second.
Yeah.
Nastia, could you zoom out a bit because
Yeah,
it's still
sure.
too small? And I guess it would be, yeah, thanks, fantastic.
Cool.
I guess on the video should be all right. Thanks.
Yeah. So for this demo, we will need to have credentials for Elastic and for OpenAI. And that's why I will be showing on my laptop. So if you have them, you can also do that with me. If you don't have it, there is like in README, in requirements, like there is a description how to get like a free trial for Elastic and for OpenAI. So you will have those credentials and you can also try it out by yourself later on. Does anyone have them so I can wait for you? Or shall I just start now? Yeah. All right. So for this demo, we need some like domain data. So here's in a solution folder, there's a JSON with some of data from Elastic Wiki. So there is not as many records as we can go with just an example. So here we have the content, summary, name, URL, and some other metadata. Usually if you have your data indexed, like you have the content itself as a large text. So it's pretty large here. It's a real text, but then you also have some metadata and they might be also important to fine tune your search because you might need to know how old is your document because maybe you want to refer only to the newest documents and you want to prioritize it. Or maybe like you have some other filters, like you want to know where it's from, like your URL or so on. So it depends how you train your retriever to show you, like to rank documents and to show you the most relevant of them. All right, so let's start with just reading this file. So here we have 15 docs. And first, same as on our presentation, we had the part where we chunk the data. So assume you have the large text, you need to break it into chunks. You can decide on the chunk size, overlap, and also delimiter. By default, it's a new line, but so you can use other of them. And yeah, you just go through it and you chunk them. And here it says, so it's from 15 documents, it chunked it into 24 passages. So like almost half of them are split. And also for that, so first we chunk it and then we create a document and we use the content and also the metadata. Here, as a metadata, we chose the name and the summary of documents. So, but as I said, you can decide on what is the most relevant for your product. So here's the summary, so shorter part, and the name is the name of the document. All right. And then here you connect to OpenAI embedding. So for this example, we just use one available. So we have the embedding and then we do the, then we put these documents in Elastic using the embedding. So basically we take the documents already chunked and then we create the embedding and we put it in Elastic as a vector database. Let's see if it works. Yeah. So that's pretty cool. And it means that we already have the index in our database with all this document there. let's go through the whole example, and then I will show you how it's stored in Elastic and how it looks like there. And then we can talk about this later if we have more time. So I don't want to focus on the product itself. I want to focus on the how to create a RAG pipeline. So for now, we created, we read the docs, so we chunked them, we stored them in vector forms. Then now we have the retrieval chain. We take it like also from OpenAI. So now we use like the most default settings, but then you can also choose a different one. So you can specify models you want, you can specify retriever you want, you can use your custom one, you can use also Elastic one. For now, we don't do that. So for now, we just use it as it is. And then we still store it in like another index, the history chat. And then we can have the question. So we can ask, for example, what is NASA? And then we can like continue the conversation. And we can make sure that the chatbot, it remembers the whole conversation, or like as much as it can remember. Because sometimes if you talk to like on a website with a chatbot, you wanted to remember the history as a part of your context. So that's what we are doing now. We have the parameter is like the chat history here. And we store all these messages in our vector database, and then we can keep them up. So
The question. So we have, in this case, we define the session, and then we have this chat history is equal to one session.
yeah. Yeah, so per session, you create a chat history. So that's context. Plus we have, as additional context, we have our domain knowledge. And then we will ask about our documents. So we will ask what is NASA. And if you would ask just a chatbot, probably you will get some responses related to the space company or to like some American company. So it's really like as abbreviations, they can stand for different stuff. And then it's one of tricky parts, and it can relate to like in pharma, you can have different abbreviations for different stuff, or in other things, in other domains. And it's one of examples of the domain knowledge you might want to know. And here we're asking what is NASA, and then we are getting the response that it stands for North America, South America. And that's why, because we actually have it in our database as it is. And then it gives you supporting documents. And then this is a list of documents. And if actually you go there, you can find the description of it. So we can try and retrieve, la, 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 yeah. So here we have our sales organization is divided into 4 regions. And then you have this information, and then what is included, and then what is that. Yeah, let's do it again. Scrolling, and then here you have the region NASA. So, and then there is several other documents. So then you can check, and when you have your own retriever, that's what you do, like you check if it actually ranked your documents in the proper way. So if it refers to right documents and if it's actually in the right order. And then you can also define how many documents you want to show. Because for some questions, if you ask what is organization, for example, in general, And then it will refer to all the documents where the word organization was mentioned. Apparently, like, it's a really bad use case. So you need to, be modest and check what can you do. Then you can also keep asking questions about that. So you can ask what the country is part of it, and then it would also it will name them, and then it will refer to exact documents. Some of them will overlap, like here, and some of them will be new ones, like others, and some of them like change the order. So it's actually ranking them in a certain order, and then like you can ask about team leads, and yeah, you can keep the chat. Of course, it has some limitations of memory. So if a chat grows too much, then it would start forgetting, because it can't keep in memory all the previous history knowledge and what you feed to it extra. Do you have some questions? Yeah.
Does the history, the memory, does it depend on the time, how long you were interacting with the chat, or the number of tokens, let's say? So that's
the history itself, so it's saved in an index, and then it has a session ID as a unique identifier, and then it doesn't matter. So you can come back to this history.
But how long does it stay? So as you say that if you are asking a lot of things,
like
it kind of, when it stops, when does the memory
it
stop?
depends. So I believe for ChatGPT it's like 5,000 tokens. So it depends. So you can check the specifications of the ML LLM model you're using. So it's usually defines, and then it's also knowing that you can also think of how much. When you split into chunks, you can think of what the size of a chunk, so how many tokens you want to add to it, because then other tokens would be about like your chat history. So that's a balance. So yeah, what to forget and what to remember and so on. Yeah. That's and then you can clean it up, you can play with it new, you can start a new session. So that's kind of like a template notebook to continue playing with it. I will now stop sharing and share my another screen where I have the Elastic open, since we have.
I have a question.
Yeah.
So in the workplace data, you have a summary. Does a human do that, or can you use ChatGPT to summarize that?
Yeah, you can.
You can use ChatGPT to summarize and then put it in the data.
Yeah, you can. So you can use whatever you want to use, right? So it's a data you have. You can as this domain data, like it can be pre-compute data, it can be generated data. So like,
yeah, I'm just wondering, like, for example, say I want to do that in my work and I have the content, but then I would have to generate the summary. So how to not have to generate the summary myself? I could just
you can just use like usually like LLMs are good in summarizing data, right?
So then that would be...
And you can then define the size, and definitely you can use it for that.
Yeah. I mean, I am giving ChatGPT my data, but maybe I can host an open source.
Yeah, so like you can give it like to, I don't know, to other chatbots if you don't like ChatGPT specifically, but
or deploy it on somewhere.
No, but you can also use the open source one and then like host it locally, right? Yeah. If you have enough computes. So other questions? Yes.
Is there in the retriever support, built-in support for information retrieval metrics?
That's a good question. Metrics, you mean for what?
Say, I want to evaluate how.
Yeah. So you have it. Okay. You have the So for there's two options. You can get the existing one, or you can get your own. For existing one, it's a question what a framework you use for it. Here I used LangChain. I can come back to code to show you. And then, yeah. So here I do it using the long chain, like here, chain. And and then you have specifications, and then you can get the metrics and you can get numbers from it. So yeah.
Thanks.
And also one of quite straightforward retrievals would be like using something like KNN. So you have the vector space and you have clusters. So if you want something like closest to your question, you can like have something like this. So there's like some naive retrievers, and then you have metrics as distance. So it really depends on the retriever what metrics you got back and what does it mean. Is it like probability, or is it like distance, or is it something else? But yeah, you definitely can get metrics back like attached to each of response. Yeah. Ask questions, or I will now stop it as well, and I will switch to the documents and show you how it looks. Yeah. So many windows. Here. So what we can see is we can like, so now I'm back to Elastic. This is bigger.
Yes.
Good to have someone in the last row to show me that.
It's also for streaming, because then it's really hard to see what's on the video.
Is it big enough?
Yes, that's
cool. So I will show Elastic really fast. How does it store data? So here we could see that we use some index. It's kind of like the name of the database. So what we can do, we can just copy paste it here, and then try to, okay, one matching index. And here we have 24 hits. And why 24? Because here we split our docs from 15 docs into 24 chunks. And then all these chunks are stored here in a way we stored it. So we decided to store some metadata as a name, as a summary. And then we decided to store some text, some part of text. So we actually stored a big part of it, as you can see. Here it stops. And then in attachment to it, we have the vector representation of each chunk. And then you have a long vector of numbers. So, and that's how the vector database would look like. So you can also not store the text itself, but store only vector and some link to another database where you have it. But in general, that's how it would look like. And then for another one, probably we can also look it up for our history. Yes. And then like we can also decide what we store from history, like sensitive, we can like de-anonymize data, we can store additional information of the session. So it's also like extra stuff. So type human, okay, data, content, respond, yeah. And like you can also store like the ID of session, and you can also store like how much time it took, what the documents you got to it. Here we store pretty simple yeah, information about this response, and then you have like others. So then you can come back to this session later since you have all the information. All right, do you have any other questions related to demo? Yes.
I'm curious. So now you actually showing that it says type AI. So does it mean that you can connect several models that they will interact with each other rather than you type in the question?
Yeah, of course. And you can also have, so that's one of like extensive solutions to how to improve the quality of your model, to use like several of them answering same question.
Right.
And then try to combine it by using another model.
Mhm.
So you can pipe models. Or it's also nice to have it stored, so then you can check the quality, for example, of communication human to human versus human to AI, if you need to evaluate your system. Yeah. And for retriever, same. So maybe you have several metrics for your retriever, and then you can just have several retrievers and then combine them together and have some scores. So like, you can, grow it up. Any other question? Okay. Then I will just go here. So that's what I meant mentioning, like we have the community blog. If you want to learn more about what is this, like how to use it, how to build these pipelines, you can come back here with more examples about that. You can also use like pre-built retrieval in Elastic. We have it, like it's also trained, and you can use it not asking the open source retriever, so then you can keep your data a bit more isolated and be less concerned about privacy. Other than that, you can also, so we have the Git repository with a lot of open stuff. We have some blogs, so with benchmarking, with a comparison of different stuff. So yeah, that's basically all we have. If you need to take a picture, I will come back here. And feel free to ask questions. And if not, just thank you for your time. Yeah.
I guess one quick question. So that was like a chatbot notebook. I also saw there was another notebook. If you can briefly explain what was the second notebook about?
Yeah. So it was actually smaller than this one. So I decided to go through another one because it has everything in it. So it's also like you do similar stuff. You just get the data, you chunk it, you add information, and then you have just question answering here. And then you have like the question is same, what is NASA? And then you have the response. And then you have sources with more reliable, like with the exact information. So it shows not only docs, but chunks you're using. So then if you split it in smaller chunks, you can make sure that it's pointing in the right part of the document, to not like user just, it refers to this document of 20 pages, just go and check. So then you can also check the overlap plus chunking, like how you want, in order to give the most precise information. Yeah,
that's actually a good point. How do you, is there a way to find the optimal size of the chunk for a given data? I guess it depends as well what kind of data.
Yeah, it really depends. So like it depends on the model, like how much it can take. It depends like what you can give to user. Like usually like you split it on quite big chunks because it splits on a like a new line. So it's like a bunch of paragraphs. So it's quite big already, like setup of data. But then you need to allow your retriever to give less documents, because you can't give like 20 of documents with several paragraphs. It's too much. So it's also about like how, like if you have documents, like I don't know what type of them, maybe you need to, like often your request will be part of quite many documents, and then you need to have chunks smaller. So it's all the balance between like what you have, what you need. Yeah, that's another document. Well spotted, Lorna. All right. I don't have, organizational information.
Yeah, maybe just close. So thank you, everybody. We hope it was useful. And we want to shortly introduce Julia. Is that okay, Aliona?
Yes, of course.
Okay, we have a new organizer. So, yeah, well, you'll be seeing her more often. She will
Yeah,
become
more often.
And our previous co-organizer who will be Mrs. Sola. Thank you, everybody. All right, we're closing.
Thank you.
Yeah, so the next steps.
All right, then. Next session, for
Yeah,
sure.
next session. So I would say we will keep in the direction of LLM, fortunately and unfortunately, because so the May events, we get some last minute cancellation. We change in the topic now, but there is a high probability that it will be about testing and monitoring LLMs. Then in June, we will have event at Molly, and it will be focused on literally what Molly did with their LLMs in a really highly regulated industry. So what is possible, what is not possible. That's more or less overview of the next steps. But the topic for May still could change. So keep.
Yeah.
Yeah,
Yes.
I think that, right. I think, oh, sorry, we're closing the streaming part, right?
Yes.
And then we have a short, we still have time for
Yeah, we still
networking
have
part.
like 15, 20
Okay, there is
minutes.
still some food left, so please help us to finish the food,
yes.
or at least take it,
We
not to
can
spoil
finish
it,
them.
and just move in that direction.